right, so I'm pretty sure where I left off was I said I was going to do some examples. And I had planned to do them on the spreadsheet. Actually, I have a whole video of me demonstrating how to use the spreadsheet template that I built for you. But upon further review, it seems that y'all need to have me talk through what's going to be asked for you on the spreadsheet so that you know how to use it better. And I know that some of you are getting confused. I want to use the formula. Let me tell you what you don't want to use. You don't want to use the formula for computing the future value of an annuity. You see that big blue box? Okay? Do you see the type right there? All right, I'm not going to hold that any closer. That's a gigantic formula. Now, if this were a finance course, sure. I'd make you learn the formula and where every piece of it came from. I've demonstrated for you how a payment grows over time. And so instead of demonstrating the spreadsheet, I'm going to talk you through the pieces that you need to pull out of here so that when you do get to my template, you are more able to use that template, or at least that's my hope. Okay? Do not try to use any formulas by hand. You'll go nuts. There are calculator programs that emulate a TI-84. That's what I have right here. It's on my phone. There are financial calculators you can purchase if that's the industry that you're planning to go into. But since we all have access to Google Sheets, let's take advantage of that. Very, 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 very few people need those big formulas, okay? Very, very few. Those are financial engineers that need those formulas. Actuaries need those formulas. You need to be able to put in the right information and to reinterpret what information comes out. So the template is going to be set up for you this way. The first thing you're going to be asked for is the payment amount. It's going to be very important on the ordinary annuities that you put in your payment amount as a negative. Why? You are investing. You are paying. Money is going away from you. So if we look at the problem I've got right here, it's invest $50 per month, blah, blah, blah. Okay. So what I would put into my spreadsheet for the payment amount is minus $50. Because even the fanciest of all the financial calculators out there needs to understand the direction of the flow of money. Negative money going away, positive money coming to. I'm paying, money's going away. I put it into the formula as a negative. The word invest tells me that the money is going away from me. When I reinterpret that mathematically, invest going away, negative 50. My annual interest rate is 5.7%. Okay? Now, if you were going to be using that big old blue formula in the book or anywhere else you might find it, you would need to convert that to a decimal. But we don't have to because, again, even the fanciest of all the financial instruments out there that do this computation for you will take this as a percent. So we're going to keep it as a percent and not throw it into a formula, okay? So you don't have to convert it to a decimal to use my template. You wouldn't have to convert it to a decimal to use the TI-84 time value of money solver or an expensive finance calculator to do so. I need the number of periods per year. Well, I'm investing $50 per month. Sounds like I'm doing that every 12 months, but this is about periods per year for interest. Interest is compounded monthly. Ooh, good. So this is an ordinary annuity. I'm making the payments, same time that I'm earning interest. 12 months in a year. How many years? 18. And that's what you would need to throw into the time value of money template that I've built for you for doing ordinary annuities. If you look in the book, you're going to see something slightly different. But since I'm not with you and not all of you have the book yet, and not all of you are able to access it, I'm going rogue. And I make it more realistic. And by making it more realistic, I make the formula even worse than what's on that page in the book. In real life, most of your investments are made at the beginning of a period. You make the payments at the beginning of the period, and interest is earned at the end. I have built that into the sheet for you, okay? You don't have to look for a new formula. We're putting money in at the beginning of a period and getting money for interest at the end. So a payment that I would make on March 1st would earn interest on March 31st. It would just sit there idle until March 31st when it got a little bit of interest and a bump. Now, the things that the spreadsheet is going to compute for you are the little I that you'll see in some of the formulas that I've shown you before, that some of you furiously have tried to use, and then I tell you, please stop. Big N, the total number of periods in the life of the loan or the investment. Okay, that's going to be computed for you so that you don't have to. And then the accumulated amount, also known as the future value, will also be computed for you. So these are the things that you'll need to put in. Everything else, just like a time value of money solver or an expensive financial calculator or a super expensive piece of software would do. Right? So this is going to be automatic. And when I say that, I mean automatically calculated with my spreadsheet. This is going to be automatic. And again, what I mean is automatically popped out from my spreadsheet. And this is going to be automatically computed based on the information that you entered. And again, I'm going to use my phone app here only because it's easier than flipping back and forth on the computer and looking strange when I'm looking elsewhere. So I need to tell it what my payments are. And my payments are $50. My payments go in as positive or negative. Is the money going away from me? Indeed it is. So minus $50. 5.7%. 18 years. Rounding off to dollars and cents. 188 and 58. A decimal. Rounding off dollars and cents. $18,858.79 will accumulate under this scheme after 18 years. But a little bit of money, $50 a month, a little bit of money at a time can grow quite substantially. Now, if I wanted to plop down a huge amount of money to start with, okay, some people can do that. I can't. You invest money, banks give you a certain rate. Banks take your money that you invested and they loan it to other people at a higher rate. And so the money keeps multiplying in its own little way. Now, I hope this was sufficient to help you understand what you need to put into the spreadsheet to do these ordinary annuity problems. But I want to repeat one more time. The formula that I'm using is different because I am making this more like what happens in real life. The investment, the monthly payments go in at the beginning of the period, and the interest is earned at the end of the period. The formulas you will see in the textbook assume that interest and payments happen at the same time. It makes a formula nice, but also makes it unrealistic. Don't want you using formulas. I want you using tools because then you can interpret your answers better. There's no present value in a situation like this because we're just making payments. All right. Ordinary annuities. Soon, talk about loans. It's not as much fun, but it's coming up. If you need me, I'm just a chat away. Google Chat's awesome.